Hello, my name is Abel Arkenbout from ToxicoWatch Foundation based in the Netherlands, and I like to present the results of our biomonitoring research in Kaunas, Lithuania 2021. The following topics will be presented: incineration, dioxin furans and PCBs, emissions, and the results of the mosses, vegetations, and the eggs of backyard chickens. And then we have some words about BOC and chemical analysis, and then the perspectives of this research. These are the EU regulated emissions for waste incinerators. The figure is based on a waste input of 100,000 tons, with the chemicals of 3,000 tons of sodium bicarbonate, activated carbon, ammonia, and a natural gas. And then it will result in an exhaust gas emission of 600 billion cube exhaust gas. And with that consists about CO2, carbon monoxide, ammonia, the NOx and the SOx and dust, and the hydrofluoride, hydrochloride, and also the PCDF and the heavy metals. Beside these airborne emissions, thousands of tons of incinerator residues like solid bottom and fly ash are as well produced, and also loaded with tremendous amounts of persistent organic pollutants, and consistent also the dioxins. And what about toxic emissions still not regulated, like the dioxin PCBs? Although already in several countries dioxin PCBs are measured, it's still not a legal base, is still not established. Also, mixed halogenated dioxins, or like the brominated dioxins, or the mixed halogenated PXB, are not regulated. Only the chlorinated substances are regulated. Substances like short chain chlorinated paraffins and PFAS are also not regulated, and it really needs a kind of regulation in the waste emission. This slide is about OTNOC. This is an abbreviation of other than normal operating conditions, and that are the conditions that the incinerator is not function optimal, and that's during shutdown and startups. And in these special occasions there is a serious risk of high emissions of dioxins. The frequency of this OTNOC, like startup and shutdown, needs to be reduced. Other potential OTNOC situations are temperature falls. For example, when the temperature is below the 850 degrees in the post-combustion zone. Or other OTNOC is some failure in the air pollution control devices. And a very important issue is the obviation of bypassing the back filter during startup or shutdown. And what about dioxins? How you can imagine in what a very tiny quantity dioxin is already harmful. We use a comparison to look like 1 grain of sand on a beach. 1 trillionth of a gram already 1 trillionth of a gram of dioxins can already cause extreme toxic effect. This are the EU. This slide goes about the EU regulations for dioxins. 7 dioxin congeners, the PCDDs, and 10 PCDF furane congeners, and 12 dioxins like PCBs are toxic and are regulated and are in the program of the GCMS analyzers. The limit for dioxin in emission is set on 0.1 nanogram TEC per normal cube, and that's already for more than 20 years, and it really needs some update because of the introduction of best available techniques. It should be updated. The regulations on food, and especially on the eggs, because that is our main topic of our research, is when the analyzers show 2.5 picogram dioxins per gram in eggs, or in the sum of dioxin, furanes and PCBs in the eggs, it will be withdrawn from the market. So the values are 2.5 and 5 picogram. There are also action limits, of 1.75 picogram per gram fat, and that is for the dioxin and the PCBs when there is a need for action, and action means that the cause of the contamination had to be found. And then this regulation for the EU regulations are only on the chlorinated compounds, and are not when the halogen chlorine is substituted by bromine or fluorine. So and also the mixed halogenated compounds are not into the regulations, but this needs to be done also. And the measurements, the regulatory measurements of dioxin emissions by the incinerator is only 0.14 a year. And this mandate is an extreme grab sampling in time domain, because how can heterogeneity of waste content, a serious issue, be counteracted by 0.14 a year? And grab sampling is really unacceptable. And when you compare also these measurements, which is short and long term, short term in 6 hours, with the long-term sampling of 2 weeks or even 4 weeks. We have done that in the Netherlands, and we find more than 1,000 times more dioxins in the sample. So it shows really that short-term sampling is unacceptable. And these measurements are also done with on optimal conditions, so no shutdown or a startup. And the deposition of dioxins are in most countries are regulated by a kind of sampling programs, like active sampling of the air, and that is done in Spain, France, and Lithuania, or passive sample, just taking it up in a bottle, the deposition. But all these sampling methods are limited. We as ToxicoWatch use another approach. We taking biomonitoring topics, matrices, and we use, for example, the eggs of backyard chickens, mosses in the surroundings, and pine needles. And we do this program in several countries like Lithuania, Spain, Czechia, French, Belgium, and the Netherlands. And now in the following slides we will discuss the results of the biomonitoring in Kaunas. At first, the results of our biomonitoring of dioxins in pine needles. We have taken samples in the direction of southwest here, and here is the incinerator located, and the distance is about 2.5 kilometers. you see at the locations 1, 3 and 6 you see double spots. That's because we have pulled the samples of these locations. The research is done with the bioassay, and the results are expressed in equivalency of 2378 tetrachlorodibenzo parodioxin, and that's the most toxic congeners. We use in our research our own ToxicoWatch indicative scale, because this research is not much done on vegetations, because pine needles and mosses are not consumer products, and the green indicates that there are low contamination levels of dioxin, and that is also based on our other research in Europe. In this slide you see several results of our biomonitoring results in the different countries, and results in the Kaunas are in the middle, and most of it you see are the color light orange, and that means that we found levels between the 0.5 and the 1.0 in Kaunas. We have also done this in mosses. We have done dioxin, PAH and PFAS in mosses, and that we find around the incinerator, within in a circle of 1.2 kilometers around the incinerator, we find all elevated dioxins, and even on one place we find an extra elevation of dioxin of 3.37 TCDD equivalent per gram mass. And when you compare it in the whole, you'll see that what we have find in the mosses are relative high compared to other results. And this is also done with an indicative scale, because the DR-Calex is a method what is not very used very often in this kind of research, so we had to rely on our own experience, because most of the time it's done with the GCMS, and what we will explain later on, GCMS has its limitations, and also the DR-Calex has its limitations, and we put together these two methods. These are the PAH Calex, and you see the result of the PAH analysis in the mosses, and are also colored red because it's compared with the other results that are elevated, and this result is compared with the most toxic PAH, that's the benzoapyrene. And so what we have found is a 220 nanogram benzoapyrene equivalent per gram mass. And these are the results of the PFAS, and that's that is pretty new, because there are not done so many researches of PFAS in mosses. The most research are on PFAS in water, but we find already pretty high levels of PFAS in the mosses around the incinerator. In this slide, the locations are shown of the backyard chicken eggs for our research 2021. The locations are predominantly located here northeast of the incinerator, and one location is located 3,000 meters west of the incinerator. Here we show you the questionnaire, because we had to know more data about our how many hens are there foraging? What is the age? Because the age is also a factor in the dioxin levels in eggs. How many eggs they are laying, per day, per month, per year. What about the housing? What about the terrain and the feed? And they're also using outdoor fireplace or all-purpose burner. All that can be confounders in our research. These are the results. And this is the results done with the screening test of the DR calyx, and we find 5 of the 6 eggs are over the limit for dioxins. So that means that they have a level of dioxins above the 1.7 for dioxins, and 4 of the eggs have levels over the 3.3 picogram tag, or better to say back, because it's the bioassay equivalent. We have verified this result with the chemical analysis, and then we find that 4 eggs are over the action limit for dioxins, and 2 of the 2 of the examples are over the limit for dioxin PCBs, and 1 egg really is more than 4 times over the safety limit for the presence of this dioxin-like PCBs. So this location really needs to be find out what is the cause of this elevation. Now, some words about the different approaches, the difficult analyze approaches. Like we thought before, the regulation is around 7 and 10 and 12 congeners of respectively dioxin furans and dioxin PCBs. All these congeners have different toxic equivalent factors, so that means that not all the dioxin congeners are toxic as one, but there is a difference. There is a difference between, for example, the tetrachlor, the tetrachloro-dibenzodioxin, and the octachloro, when there is 8 chlor. The difference is the TCDD has a TEF factor of 1, and the octachloro-dibenzo has a toxic equivalent factor of 0.0003. So that's a big difference in toxicity. And what we do with the DR calyx is that we measure the whole toxicity of a mixture, while the chemical analysis, which is only on congener level, only takes a small part of the whole group of the possible toxic congeners. So most of the time the DR calyx, the measure, the values are higher than the GCMS, and that is logical because it's taking a whole group instead of only 29 congeners. And what is also a very important aspect is that the GCMS is only concerned on the chlorinated compounds, while the DR calyx is also taken the brominated and the mixed halogenated dioxins. Here you have a fingerprint of the dioxins in the eggs of Kaunas. We have given it a dark red color because you can to compare this fingerprint with the fingerprint of the incinerator, but we don't have at this moment a fingerprint of the Kaunas incinerator, and so we have compared it with the fingerprint of the incinerator RAC in the Netherlands, and that's the result of 20,000 hours. So it's not 6 hours because that is really too short, but 20,000 hours inclusive some startups and shutdowns, and then you get this pattern, and you see that the patterns looks more or less the same. But what we need for this research is the fingerprint of the incinerator of Kaunas, and that must be obtained by long-term sampling. Semi-continuous measurement is needed, not short-term. And we need also information about the occurrence of startup and shutdowns and other ad-hoc situations to know how what is the performance of the incinerator in Kaunas. Here you have some results of our research in Belgium, and that is when you do on consumer levels. It's a multi-year program. We have done here a zero measurement, so when the incinerator is not operating, and then we have done a research when the incinerator was operating a year, and then we have done analysis on the X, and we compare the difference, and here the elevation of the dioxin congeners after 1 year of operating, and you see there's a big elevation of more than 600% of in this case from the heptachlor furanes, and that's a typical congener from the incinerator. And here we have going back. This is an old study, but here we start with our researchers. That is in the Netherlands, and when an incinerator was built in the north of the Netherlands, and it's mostly agriculture. There are no heavy industries, and we did research on eggs of backyard chickens, and we find that around the incinerator a lot of red spots, meaning all over the limits of safe consumption. And when you're going away from the incinerator, you found eggs who are safe for consumption. So this gives a really good indication the incinerator was not performing well, and we have find out the reasons why. It's a long-term study of more than 3 years we have done on this incinerator. This new built incinerator and a state of the art. It's the most newest incinerator in the Netherlands. This is a study done on a more old incinerator, operating more than 20 years in the big city of Paris, and there you find very high levels of dioxins, more than 6 times going over the limit of safe consumption. So it's really a challenge to eat some eggs there in Paris. That's an ongoing study to find out how that is possible that these eggs are so contaminated with dioxins. So to conclude this, we give some recommendations to reduce the dioxin emissions, and this biomonitoring research gives a warning signal for toxic substances such as dioxins, PCBs, PAH and PFAS in the environment of Kaunas. Continuing of the data of biomonitoring for better understanding of emissions in Kaunas. And we really had to find out the sources of dioxins and dioxin PCBs in order to take measures to eliminate or to reduce the contamination. And we really need the cooperation with the authorities and also with the management of the waste incinerator to obtain fingerprint of dioxins, of the flue gases in long-term sampling, and also during startup and shutdowns. And the cooperation with the government and waste incinerator measurements, to carry out this long-term measurement of flue gases, because that's a way to eliminate or to reduce the hazardous substance into the environment. And with this, I would thank you for your attention.